Welcome back, everybody. Today we're going to talk about equations of planes, which is the second half of our section called equations of lines and planes. So, in order to get the equation of a plane, we need two things. The first thing you need is you need a point, let's say point P, we'll call it point P naught, X naught, Y naught, and Z naught. And we also need a normal vector to the plane. So a normal vector, by definition, is a vector that is perpendicular to the plane. And we're going to call the vector A, B, and C. All right. Let's do a little bit of math, because I think that that's going to really help. So let's just say that we want to define a plane. All right, so we have our point P naught P, and we'll have a point P out there, which will just be X, Y, and Z. And that's some other point on the plane. So in order to get vector P naught P, we need to do final minus initial. So if my final point is X, my initial point is X naught, it's X minus X naught, Y minus Y naught, Z minus Z naught. So there is my vector in the plane. Now, if I'm saying that P naught P is in the plane and N is normal to the plane, then if you remember in our dot product, what we said was that if we had P naught P dot N, that would equal 0 because they are perpendicular. Because they are perpendicular. So let's do the dot product of those two things. So if I have X minus X naught, Y minus Y naught, Z minus Z naught, dot ABC, that should equal 0. Now remember, your dot product, right, yields a scalar. So let's do the multiplication. So I have A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught, and the whole thing equals 0. This is indeed scalar form of equation of a plane. Now, basically what's going to happen is I'm going to do 3 or 4 examples, but all roads are going to lead back to this template. So I would say pause the video at this point, write this down, and afterwards we'll do just a little bit more algebra. Or actually, while you're paused, why don't you just do a little bit more algebra and do a little distributing, and we'll see where we wind up. All right, so if you did some algebra, right, we're going to distribute our A, distribute our B, distribute our C. So I get AX minus AX naught plus BY minus BY naught plus CZ minus CZ naught equals 0. All right, now remember that I'm going to change color for just a second. This one, and this one are all constants, right? X naught, Y naught, Z naught was a definite point. They were constants. A, B, and C were numbers. So we can add them all to the other side. So we wind up with AX plus BY plus CZ equals AX naught plus BY naught plus C Z naught. Now again, since all three of these are constants, we can rewrite it as, right, combine like terms, and we say it just equals D. All right, so a couple things that I want you to know. Now at this point, this is what you need to know. I'm going to give you a couple of problems where I'm just going to vary the information given. All right, but something I'd like to point out over here, notice the coefficients on X, Y, and Z. All right, if you remember, that was our normal vector. Our normal vector was A, B, and C. So it's right in the equation. Now, another question I'd like to ask is, if I had two vectors in a plane, could I find the normal vector to both of those two vectors? The answer is yes. I would use the cross product. So those are two things to keep in mind because, like I said, as I vary the information, all right, keeping that in mind is going to be really, really helpful. All right, so let's try example 1. Example 1 is going to be pretty basic, but we'll work up from here. All right, so it's going to be find the equation of the plane through let's say P naught, -3, 0, 7, and perpendicular to vector n, which is 5i plus 2j minus k. All right, well, I told you at the very beginning you needed a point in the plane and a vector normal to the plane. This example 1 has given you both. So if your teacher gives you this example, you should quietly smile and realize that we're just going back to our framework right here. Right? Because I have my A, B, and C. I have my X naught, Y naught, Z naught. So I can substitute. All right? So why don't you pause the video, substitute the various numbers in, and then we'll see if we're on the same page. All right. So I got 5. And remember, we had our second point, X, right, minus -3, plus, now B is 2, so 2 times Y minus 0. Don't have to put in the 0. I like putting it in right at the beginning to know that my bases are indeed covered. Then my C is -1, so I'm just going to put -1 here. And then Z minus 7, and the whole thing equals 0. All right, at this point, as always, we just have some algebra to do at this point. So I'm going to ask you to pause the video, work on some of the algebra, and then we will, I'll show you the answer on the back end. All right, so minus minus is really a plus. So when I do my distributing, I'm just going to say 5x plus 15 plus 2y. And then I'm going to say minus x plus 7 equals 0. And then I'm going to take my 15, and my positive 7. And I'm going to subtract them over to the other side. And I'm going to wind up with 5x plus 2y. I had a minus x over here. I should have put minus z. That's okay. It happens every once in a while. Just make sure that you're putting the right letters in the right places. And it equals negative 22. All right, so again, the most basic example, I've given you exactly what you needed to find the equation of a plane. And it was done pretty easily. All right, here's our next example. I saw someone do this example once, and I thought it was interesting because it brings in some old skills. If you note it, right, it says find the equation of the plane containing point 3, negative 4, 5, and the line, and it gives you the symmetric equations, right? So we're accessing an old skill of symmetric equations in an effort to do a current problem. So remember, we need two things. The first thing is we need a point in the plane, and that is point 3, negative 4, 5. All right. Now, we need a vector normal to the plane. Do we have a vector normal to the plane? I don't see one. So we need a second point on that line. How are we going to get that is the question. I'm not 100% sure, but I do know that my symmetric equations have some direction numbers in them, don't they? So I can get, let's say, I'll call it vector B, and I'll say that that is 2, negative 3. That's a terrible 5. I'll make that a little bit better. Right? And that's a vector for this particular line, right? Okay. So now what are we going to do? We need a second point. So let's pause the video. Let's think about this for a second and come back and discuss. All right, so I'm looking at my symmetric equations, and I'm thinking, what number for x, y, and z could make all of them be true? Well, if I put in a number for x that would make the numerator equal 0, I could easily find a number for y that could make the numerator equal 0. I could find a number for z that would make the numerator equal 0. And if that statement is true, that particular point should be on the line. So, let's see, for x, I would put 2 in. 2 minus 2 would be 0. For y, I'd put negative 1 in. Negative 1 plus 1 would be 0. And for z, I'd put in negative 3. Negative 3 plus 3 would be 0. So I'm going to call my point Q 2, negative 1, negative 3. And I'm going to say that that is a point on the line. Now, the question is, and I'm going to ask you to do this, is find vector PQ, and then we're going to do the cross product with V, because vector PQ and vector B are both in the plane, and we need a vector normal to both. So you're going to do final minus initial. So for vector PQ, I've got 2 minus 3 is negative 1. I've got negative 1 minus negative 4 is going to be plus 3. And then I've got Negative 3 minus 5 is negative 8. And then I'm going to cross that with vector b, which is 2, negative 3, and 5. All right. So I helped you get the vector. Why don't you guys do the cross product, and I'll give you the answer on the back end. We've done plenty of cross product through our journey together. Let's see how you do this time. All right. If you had trouble setting up the cross product, I'm going to try to help you out a little bit. So I got I, J, and K. And I'm going to put in my negative 1, 3, negative 8, and then 2, negative 3, and 5. I like doing the determinants, and I like writing everything out. To me, it's helpful. And so what do we get? Well, so I get negative 5. Hang on. So I get, hang on. All right, so if you wrote out the determinants, your final answer should be negative 9i minus 11j minus 3k. And I'm not so keen on having a lot of negatives. So I'm going to divide everything by negative 1. So I'm going to say my normal vector, 9i plus 11j plus 3k. And you could have used either one. It's just a matter of how you want to do your algebra. And, you know, like I said, if you don't care about the negatives, just use the one you get out of the cross product. If you do, then you can divide by negative 1. So I'm going to put it into my framework. 9 times x minus 3 plus 11 times y plus 4 plus 3 times z minus 5, and that all equals 0. Now, so notice, the reason why I didn't want my negatives was because I have my, right, I got to do my distributing. And it's just a personal preference. Like I said, it's not a huge deal. So why don't you guys do the algebra, and I'll give you the answer on the back end. All right, so hopefully you guys paused the video and did the algebra. I got an answer of 9x plus 11y plus 3z, hang on, equals, not 0, just kidding about that, negative 2. All right. So let's shift to the next problem. I'm going to just scroll down a little bit. Find the equation of the plane with a, so find the equation, EQU, of the plane with point 3, 6, negative 2, and parallel to the plane to x plus 3y minus z equals 4. All right. So I like this problem. Like I said, I've seen this one done before. I like this problem because there's a little bit of a conceptual kick to it. All right, so we're finding the equation of some plane that's parallel to a different plane, right? So if I were to get a normal vector to this plane, wouldn't it be a normal vector to the plane that I'm looking for? Because they're parallel. So the answer is yes. So I have my normal vector is going to come right off the plane that I was given. 2, 3, -1. And I have my point, 3, 6, -2. All right, now I'm going to put it right into my framework. So I'm going to say 2 times x minus 3 plus 3 times y minus 6 minus 1 times z plus 2 equals 0. Once again, I'm going to ask you to pause the video, do the necessary algebra, and we'll talk about the answer on the back end. All right, so hopefully you did the algebra okay, combined your like terms. Your final answer should be 2x plus 3y minus z equals 26. All right. So I've got 1 or 2 more. And again, these are not necessarily problems that I made up. These are ones that I've seen before. So let's do the next example. All right, so here's our next example. Find the equation of the plane containing point P, 2, 1, 1, point Q, 0, 4, 1, point R, -2, 1, 4. All right, so it's not the example I wanted to do. I can change up the points, that's no big deal. We'll call it -1, 2, 4. All right, I'm changing up the example a little bit on the fly, but again, I've seen this problem done before. I like it, like I said, because it calls up some old skills that we need. So I'm asking for the equation of the plane, but I'm only given 3 points. So I have a point in the plane. I have 3 of them. I have too many. Then now the question is, I need a vector normal to the plane. Well, we know to get a vector normal to the plane that probably cross product is going to be involved. But the first thing I need before I can do cross product is I need 2 vectors in my plane. So I'm going to ask you to get vectors PQ and PR. All right, so again, this is the first skill that we're recalling from prior sections, which is how to get these vectors. So I'm going to ask you to pause the video, get the vectors, and I'll talk about the answer on the back end. All right, hopefully you paused that video. So I got vector PQ as -1, -5, and 4. And vector PR as -3, -1, 5. Now to get a vector normal to both, I need to do the cross product of vector PQ and vector PR. So I'm going to set up my 3 by 3 determinant, which would be I, J, K, -1, -5, 4, -3, -1, 5. All right. So again, the next skill that we are needing to recall from a prior section would be cross product. We've done this already. So why don't you guys knock out that cross product and we'll work with the answer on the back end. All right, see you soon. All right, so, right, I have -21i minus 7j minus 14k. Now, we already know we're going to have to do some algebra with these numbers. So having larger numbers doesn't necessarily suit us, does it? But what we can do is there is a common factor of 7 here, right? So we can factor that out to the side, right? Or divide everything by 7, or -7. And I wind up with 3i plus j plus 2k, which again is a parallel vector, but again, still normal to our plane. We have smaller numbers. We've got nice positives. So I'm going to combine this, right? This is our normal vector we're going to use. And our point is, we'll use point P. Doesn't matter which point you use, I guess, but why not P? 2, 3, 1. And again, we're going to fill in our framework. So we're going to say 3 times x minus 2 plus, all right, now we got a 1, so that's why I didn't put anything there. Y minus 3 plus 2 times z minus -1, right? That should have been a negative there, right? On my P, I think. No, 2, 3, 1. Yeah, 2, 3, 1. So -1 equals 0. All right, let's do a little bit of algebra and see how we wind up. So I got 3x minus 6 plus y minus 3 plus 2z minus 2. All right, so then I wind up, I add, so I get 3x plus y plus 2z. 6 plus 3 is 9, and 2 is 11. So I wind up with an 11 there. All right, so let's move to the last problem. All right, let's scroll down. All right. The last problem we're going to look at is finding the distance from a point to the plane. All right. So we're going to find a distance from the point to the plane. So I'm going to say my point is S, 113, and my plane is 3x plus 2y plus 6z equals 6. Now I'm going to use D equals dot my normal vector over the magnitude of my normal vector. So, all right, we now need to figure out a second point. So why don't you guys pause the video? Or actually, you know what? Let's start with our normal vector. Our normal vector should be okay, right? We have a 3, we got a 2, we got a 6. Seems like a pretty good normal vector, right? And we can also do the magnitude of our normal vector. So I like this because, again, it brings in a prior skill. So under the square root, I'm going to say 3 squared plus 2 squared plus 6 squared, right? And that equals the square root of 49, which equals 7. So I have the first two pieces. Now I want you to pause the video for just a second, and I want you to think about how to get that initial point P, because we need to get our vector PS. All right. All right. Hopefully you pause the video to think about it. All right. So let's say I wanted to get, let's say, like the Y-intercept of this particular plane. I would set X, I would let X equals 0 and Z equals 0 and solve for Y. So that would wind up being 2y equals 6, y equals 3. So I can say that point P is going to be 0, 3, 0. All right. So now I'm going to scrunch this up a little bit because I can get my point S in there. So now I need vector PS. So I have point P here, I have point S here. Why don't you guys run through, get vector PS, and then we will talk about it on the back end and what to do with it. All right. Hopefully you paused the video. You took P and S and got a vector out of it. So I'm going to scroll up. So I'm going to say vector PS equals, I got 1, -2, 3. Hope you got the same. And if I need my, according to the thing, I need my normal vector over the magnitude. So my magnitude is 7. So I'm going to do 3/7, 2/7, and 6/7. All right. So, and what do I need to do with these? I need to do the dot product. Okay. So I'm just going to set up my dot product right away. So I'm going to say D equals absolute value I minus 2j plus 3k, right? Because that's my vector PS. And I'm going to dot that with 3/7 I plus 2, I'll make a better 2 out of that. 2/7 j plus 6/7 k. And again, that is my normal vector divided by my magnitude. So why don't you guys run through, do the dot product, and we'll talk about it on the back end. All right, hopefully you paused the video. I got 3/7 minus 4/7 plus 18/7. That whole thing equaled 17/7. So that is your distance from the point to the plane. All right, we've run a little long, but we had some interesting examples that recalled some old skills. I always like that. All right, so thank you very much for listening, and I'll see you all again soon.